Hey guys, how's it going? Welcome to this video 10.3 Arcs and Chords Part 1. Now, I don't actually remember if we've talked about chords or not, so just really quickly, a chord is a line segment in a circle, and both endpoints have to be on the circle. Usually we don't talk about the radius and the well, obviously not the radius, but usually we don't talk about the diameter as being a chord. So if it goes through the exact center, then we're just going to say that's the diameter. But if it doesn't go through the center, if it just is like this one here, AB, then we're going to call that a chord. So a chord is just a line segment with two endpoints on the circle. And you guys already know from previous videos what an arc is. An arc of a circle is a portion of the circle or a part of the circle. So in this video, we're going to talk about arcs and chords and the relationships between arcs and chords. One thing that you have to know about arcs and chords of a circle is that if you have a circle and if you have two chords that are congruent to each other, like in this picture, they're showing us that chord AB is congruent to chord CD. So if you have two congruent chords in a circle, then the arcs are going to also be congruent. So this arc AB is congruent to this arc CD because the chords are congruent. So that works in any circle. If you have a circle and if you have two chords that are congruent, the arcs will be congruent, and vice versa. If the arcs are congruent, then the chords are congruent. Once you know that, you can solve a lot of simple problems just like this one. In this problem, they say the measure of arc AB is 60 degrees. What's the measure of arc CD? The answer is 60 degrees because they are congruent. Let's take a look at another type of problem. In this problem here, we have two different circles. Now, first we have to know that the circles are the same size, and they are because the problem tells us that circle J is congruent to circle K. So once we know that the two circles are congruent, then we can apply the same rule that we learned before, which is if the arcs are congruent, then the chords are congruent. If the chords are congruent, then the arcs are congruent. So in this problem, they're telling us that arc MN is congruent to arc PQ, and they want us to solve for x. So to do that, we can say 2x plus 1 is equal to 3x minus 7 because the chords are going to be congruent now. And then we can solve it to find out what x is equal to, and we get that 8 is equal to x. So once you know that the arcs and the chords are connected to each other, if one of them is congruent, then the other one is congruent, then you can solve lots of problems like this. Go ahead and try this next problem on your own. All right, here's the answer for this problem. Because arc RS is congruent to arc TV, we know that chord RS is congruent to chord TV, so we can say 5x minus 9 is equal to 2x plus 3. Then we can solve this for x, so let's subtract 2x on both sides, add 9 on both sides, so 3x is equal to 12, which means that x is equal to 4. All right, that was the warm-up. Now on to the fun stuff. All right, I have here a circle and I have a chord, and what I want you guys to do is imagine drawing a line that bisects the chord. Remember, to bisect something, it has to cut it exactly in half, so exactly in the middle, the midpoint. It has to bisect the chord, and it has to be perpendicular to the chord. So imagine what that line would look like. A line going through the chord that is a perpendicular bisector. That line might look something like this. So I tried to make it a perpendicular bisector. Now imagine if, let's say that this is the center of the circle. Imagine if that perpendicular bisector continued to the center of the circle. Ta-da! Perfect. Okay, so we have a perpendicular bisector. It is now toward the center of the circle. Now let me just delete the part that went outside. Phew, okay, that took a lot of work. So now we have a perpendicular bisector, and what else do you notice about that yellow line? It also happens to be a radius of the circle. And if I continued to draw the yellow line all the way across to the other side of the circle, it would be a diameter. So what we have just discovered is, if you start with a chord, which is the blue line, and if you draw a perpendicular bisector to the chord, it just happens to be a radius, or a diameter of the circle. That's actually kind of like the next two theorems that we're going to talk about. It's okay if you haven't written down a ton so far today. Go ahead and write down these two theorems here. You can draw one or both of the pictures. They're basically the same thing, but you would probably want to draw the little congruent lines here. And then for the theorems, the first theorem is saying if the diameter is perpendicular to the chord, then the two segments x, z, and zy are congruent to each other, and the two parts of the arc, x, b, and by, are congruent to each other. So if a diameter is perpendicular, then it bisects. Then it's a bisector. The other theorem is saying if you know that something is a perpendicular bisector, then it's automatically going to be a diameter or a radius of the circle. So for the rest of the video today, we are going to use these two theorems to help us solve different problems. We're actually only going to do 4 problems. I'm going to do one, then ask you to try one, then I'm going to do another one and ask you to try one. And those 4 problems are going to be using these two theorems here, which say that if a line is a perpendicular bisector to a chord, then it is also a radius or it's a diameter. All right, here's the first one. I'm going to do this one for us. In circle S, the measure of arc PQR is 98. That means that the measure of PSR, the angle, would be 98 degrees, just a side note. But that's not important for this problem, but it is important in general. Okay, so the measure of arc PQR is 98. They want us to find the measure of PQ. So the whole thing, PQR, is 98. This part of it, PQ, that's going to be half of 98. So 98 divided by 2, that's going to be 49. Now, how did I know that it was half? Well, by looking at my picture here, I noticed that QS is a radius, and I noticed that I have a little perpendicular symbol, and the theorem, the first theorem, said if something's a radius, and if it is perpendicular to the chord, then it's automatically a bisector. So that's how I knew it was half, because our theorem says it's a bisector. So the answer is that PQ is 49. Go ahead and pause the video, try this problem, then you can check your answer. Just like the last problem, this one's pretty short. In circle S, they want us to find the length of PR. PR is this entire chord right here, and they give us that half of the chord is 6, which means this part is also 6, which means the entire chord is 12. 6 plus 6 is 12. Now, how did we know that the other part of it was 6? Well, we knew that QS was a radius. We knew that QS was perpendicular to the chord. According to the first theorem, if a radius is perpendicular, then it is automatically a bisector as well. All right, this problem's going to be a little bit more fun. It's not going to be quite as simple and straightforward as the last 2 problems. We're going to actually have to do some math in order to get the answer here. In the stained glass window, diameter GH is 30 inches long, and chord KM is 22 inches long. Find the length of JL. So JL is right here, that's what we're looking for. I notice that in this picture of the circle, they have already given us a huge hint by doing a dotted line from J to K and a little right angle symbol, because that's a right triangle, and we can do lots of things with right triangles. We can use sine, cosine, and tangent. We can use the Pythagorean theorem. So let's think about how we can solve this problem. In this right triangle, if I knew the length of KJ and the length of K, this one doesn't have a point here, but the other one, you know, K to this point right here, if I knew those other 2 sides, then I could use the Pythagorean theorem to find the last side, JL. Do I know what those other 2 sides are? KJ. Do we know the length of kj? Well, they didn't give us the length of kj in the problem. Kj is what in the circle? Is kj a chord? Is it a radius? Is it a diameter? What is kj? Kj is a radius. Okay, do we know the length of the radius of a circle? In this problem, no, but we do know the diameter. They said the diameter is 30, which means that a radius is going to be 15, because all radii are going to be 15 in this circle. So we know that a radius is going to be 15. Now, do we know the other one? Well, they did tell us that chord KM is going to be 22 inches long, and this is half of 22 from here to here, so that's going to be 11. So now we can use the Pythagorean theorem to find the third side, which is JL. So we can say x squared plus 11 squared equals 15 squared. 15 is the hypotenuse of the right triangle. Then we can solve it for x. X squared plus 121 equals 225. We can subtract 121 from both sides. So x squared is going to equal 104, and then we need to take the square root of both sides. And we will get that x is equal to 10.2. So that's our final answer. The length of JL is going to be 10.2 inches. All right, we only have one more problem left for you guys to try today, and that is very similar to this problem. So go ahead and take one more look at this problem before you try one on your own. Go ahead and pause the video here, try this problem, and then you can come back and check your answer. All right, so here we're trying to find the length of TV. This is 5 and this is 6. Let's see, if I draw a right triangle here, and if I solve for x right here, then I can double x, and then I can get the length of TV. So let's see if I can solve for x. In this right triangle, I know that this side here is 6. The hypotenuse is a radius of the circle. Another radius of the circle is UR. UR is also a radius. UR is 11. So that means that VR is 11, because all radii of the same circle would have the same measure. So that's 11, that's 6. So in this right triangle here, I could say 6 squared plus x squared equals 11 squared, and then I can solve it for x. All right, then we subtract 36 from both sides. Then we square root, and we get 9.2. So 9.2, that's the length of not TV, but just half of TV. So the problem said to find what TV is. So now we're going to do 9.2. Oh, whoops, they said round to the nearest hundredth. Okay, 9.22. There we go. It was supposed to be 9.219. Okay, so 9.22. Now we're going to double that to get the full length of TV, which is 18.44. That is our final answer for this problem, 18.44. All right, great job today. Go ahead and make sure your notes are submitted on Canvas, and that is it for this video.